13-6 Conditional Probabilities and Formulas. With conditional probabilities, you can have probability of A and B when A and B are dependent on each other. We did independent probabilities earlier. This time B's value changes when A has happened. The formula, though, is still probability of A and B equal the probability of A times the probability of B. An example of that is in a bag of marbles, there are 2 black, 3 red, 2 yellow, and 4 blue marbles. If you select 2 marbles out of the bag and don't replace the first, what is the probability that you select 2 blue marbles? So if you look at your blue marbles, there's 4. We have a total of 4 plus 2 is 6, plus 3 is 9, plus 2 is 11. So we have 4 out of 11 for our probability of getting a blue marble. But now we've taken 1 out of there. So that leaves us with 10 marbles in the bag, and we took out a blue, so there's only 3 out of the 10 left. We multiply that together, and we get 12 out of 10, 110. If you want to simplify that first, you could, but since we're using a calculator to find the percent, we can just go through and multiply them straight. So we have 0.10909, which is 11% when rounded. Not quite sure why I wrote 10%. That would be 11%. So the other type of probability we're going to have is our conditional probability. For any events A and B, the probability of B occurring, given that A has occurred, is probability of B given A equals probability of A and B divided by the probability of A, where our probability of A cannot equal 0 because, again, we can never divide by 0. So my example of this probability is at a recent swim meet, half of the swim club members experienced an improvement in their race times over the previous meet. The probability of a swim club member experiencing an improvement in their race time and training the week before the meet was 30%. What we are asked to find is what is the probability that a swimmer trained the week before the meet given that his or her race time improved. So you're looking at the trained given that they improved. So we're going to try and find the probability of improved and trained divided by improved. So if I think about the probability of where they trained and improved, I go back to the sentence in here that half of the swim club members experience an improvement in the race over the previous meet. So that was our improving. Half is 50%. The probability the swim club member experienced an improvement in their race time and training in the week before was 30%. So that's 30% is our trained and improved. So we're going to put our trained and improved divided by our improving. So that is our 0.3 or 30% divided by our 50%, 0.5, which is equal to 0.6 or 60%. Another example, in a research study, 1/3 of the volunteers received drug A, 1/3 received drug B, and 1/3 received a placebo. Out of all the volunteers, 10% received drug A and got better, 8% received drug B and got better, and 12% received the placebo and got better. So what is the conditional probability of a volunteer getting better if they were given the placebo? So you're looking for better given the placebo. So you do the placebo and better, and the probability of just the placebo. So, probability of the placebo and better was my 12%. Of just the placebo itself, 1/3 received the placebo. So 1/3 is 0.33 or 33%. And then I divide those two. So I go 12 divided by 33. And that is equal to 0.36, which is 36%. And those complete the example problems.